All right, everybody, we are on number 11. We're getting through this, I know, but if you had known what I've been through for the past 30 minutes, I literally have taped this one question 2 times. My dogs came in, my boys started yelling at their mother. Okay, as you can see, it is all marked up. Okay, I've been doing a lot of work. In fact, this is the second booklet that I've already done, and the reason I wanted to spend so much time on this one question is because it's a really, really good question, okay? Let's read it, and I'll kind of talk through it as to why it's a great question. At a university, Todd deposits. What do you automatically think of when you see that word deposit? Bank, of course. And we also think of simple interest. We think of compound interest because we were talking about financial literacy when we use that vocabulary. So if you deposit $100 into an account, are you adding it or are you subtracting it, multiplying? You're adding it. It's a good thing. Let's keep reading. He spends $5 on dinner. And as you can see, I noted that this was an important word. If you spend something, are you adding it to your original $100 or are you subtracting it? Absolutely. You're subtracting it. So he spends $5 on dinner every day. Yes, the cat's out of the bag. I always circle. I love these words, and here's why. When you see the word every, when you see the word each, when you see the word per, you know what? What did we say that these words always go in front of? X. We're not talking about interest. We're not talking about compound, simple interest. I bet we are going to be solving an equation and looking for the variable, okay? I'm putting that on the back burner, but I'm starting to change my thinking and starting to put my mind in the mode of, I'm not going to be using that interest. And that's why it's important to always read through these problems from the beginning, read it through once, and then read it again. Okay, so we know that $100 into the account, spends $5 every day. Now we switch to Seth. Okay, we're talking about Todd, and then now we're going to talk about Seth. Okay, Seth, he deposits $140. Same thing. He starts with a little bit higher amount into his account. And he spends $5 on lunch, $5 on dinner every day. It doesn't tell us how many days, but he spends more per day than Todd does. Todd is $5 dinner only. Okay, he's trying to save money, doesn't go out to lunch. Seth, he eats out a lot. Okay, so he's spending $10 a day. Okay, I'm going to keep on reading, and I see the word every day. Same thing. So X has now become our variable that we have an unknown value that it's going to represent. So I keep reading the question. It says, after how many days? So the question is, how many days, isn't it? Okay. Well, Todd and Seth have the same amount. And when we see the word same amount, we think of the word equal. What's another word that we use in place of equal? Okay, if we were talking about angles, we might say congruent. They are equal. And what is a symbol that we could use for the same amount, equal or congruent? You bet. We are dealing with an equation, okay? So our variable, X, is going to represent what? Number of days. Okay, so they want to know when will, when will Todd and when will Seth have the equal amount of money in their account after so many days. And to take that even further, how many of you remember this? If Todd started here and he subtracted a little bit out of his account every month, we notice he's subtracting money, isn't he? But Seth, he started out a little bit more, but he spent more per day. Okay, what does that look like? When they meet, it is called the systems of equations, or the solution. Okay, and I'm pointing this out because you will definitely have a question on systems of equation. It's when the solution, and we're going to talk about this in a minute, when you have two expressions or two equations that are equal to each other. And we've solved for one variable. Okay? So for example, this may be the number of days, and this is the amount of money in their account. Okay? But we're going to put that to the side right now. And that's just kind of a talking about another TEK that we might talk about, another question that you may be quizzed on. The systems of equation is the ordered pair for this point. You would have an X and you would have a Y. Okay? Put that to the side. Let's look at Todd. He started with $100 in his account, but he spent, and we said he was going to be subtracting from his account how much per day? $5 times the number of days. We don't know the number of days, and that's what algebra is all about. Using the relationship of what we do know to find out what we don't know, which is the number of days. Let's look at Seth. He starts with $140, and he subtracts how much per day? Not 5, but 10. Okay? And I apologize, that is an actual 10, but it doesn't look like it, does it? Now what do we have? Does this look like something that you've done before? Absolutely. So, okay, Ms. Kowalski could probably solve. I could handwrite this. I would, if I add it, and basically I'm combining like terms. But you were given this wonderful, wonderful tool this year, weren't you? And what was the operation or the resource on the calculator that can solve for a variable with an equal sign? So when you have an equation, you always use the end solve. So you use your menu, and it is algebra, which is going to be toggle 3, and we're going to use the numerical solve. Okay? And then always make sure that you write your equation within the parentheses. So I'm going to enter that, and I have 100 minus 5x, and it should look like that, is equal to Seth, which is 140 minus 10x. Okay? So here I have an expression for Todd and an expression for Seth, and I set them to be equal to each other. But here's the most important part. When you use end solve, you always put a comma and the variable that you are using in your equation and press enter. And the answer is 8, which is B. Okay? Now, is there another way? Maybe you forget end solve. How can we justify that answer? If we know, we could substitute this variable, this numerical value back into Todd. If he spends $100, or I'm sorry, he deposited $100, 5 times 8 is 40, 100 minus 40 is 60 in Todd's account. Okay, Seth had 140, and he subtracted 10 times 8 is 80. 140 minus 80 is what? It's 60. So using those two expressions, I was able to justify the answer that came out of my, I apologize for this, when I solve for x. Okay? Always remember, don't stop when you think that you have the answer. Always find another way to either prove that it's the right answer or prove that another answer is the wrong answer. These tests are not only about finding the right answer, but really eliminating the other ones. Okay? We'll see you on question number 13.